Good morning to all of you. I am LakshyaVerma, currently pursuing my Bachelor of Technology degree in Production and Industrial Engineering from University Department, Rajasthan Technical University. Today, I am pleased to be here in front of you all to deliver the presentation of my seminar topic Smart Materials. The first one slide is contents. First one is introduction, and second one is properties of smart materials, classification of smart materials, shape memory alloys, thermal hysteresis, applications, and advantages and disadvantages. And the last one is conclusion. So the first slide is introduction. Smart materials have properties that react to changes in their environment. This means that one of their properties can be changed by an external condition such as temperature, light, pressure, electricity, voltage, pH, or chemical compounds. This change is reversible and can be repeated many times. The next slide is properties of smart materials. It has properties that react to change in their environment. This means that one of their properties can be changed by an external condition such as temperature, light, pressure, voltage, or chemical compounds. This change is reversible and can be repeated many times. Here are some points: sensing materials and devices, actuation materials and devices, control devices and techniques, self-detection and self-diagnostic. The next slide is classification of smart materials. First one is piezoelectric materials. There are materials that produce a voltage when stress is applied. Since this effect also applied in a reverse manner, a voltage across the sample will produce stress within sample. Suitably designed structures made from these materials can be therefore made that bend, expand or contract when a voltage is applied. And the next one is shape memory alloys and shape memory polymers are materials in which large deformation can be induced and recovered through temperature changes or stress changes. The shape memory effect results due to the respectively martensitic phase change and induced elasticity at higher temperatures. Third one is photovoltaic materials or optoelectronics convert light to electric current. Electroactive polymers. It changes their volume by voltage or electric fields. Magnetostrictive materials. It exhibits a change in shape under the influence of magnetic field and also exhibits a change in their magnetization under the influence of mechanical stress. Magnetic shape memory alloys are materials that change their shape in response to a significant change in the magnetic field. Smart inorganic polymers showing tunable and responsive properties. pH sensitive polymers are materials that change in volume when the pH of the surrounding medium changes. Temperature responsive polymers are materials which undergo changes upon temperature. Halochromic materials. They are commonly used materials that change their color as a result of changing acidity. One suggested application is for paints that can change color to indicate corrosion in the metal underneath them. Chromogenic systems. The change in color in response to electrical, optical, or thermal changes. These include electrochromic materials which change their color or capacity on the application of voltage. Thermochromic materials change in color depending on the temperature. And photochromic materials which change color in response to light. For example, light sensitive sunglasses that darken when exposed to bright sunlight. Ferrofluid are magnetic fluids affected by magnets and magnetic fields. Photochemical materials change shape under exposure to light. Polycryptolone can be molded by immersion in hot water. Self-healing materials have the intrinsic ability to repair damage due to normal usage, thus expanding the material's lifetime. Dielectric elastomers are a smart material system which large strains up to 500% under the influence of an external electric field. Magnetocaloric materials are compounds that undergo reversible change in temperature upon exposure to a changing magnetic field. Smart self-healing coating seal without human intervention. Thermoelectric materials are used to build devices that convert temperature differences into electricity and vice versa. And the next slide is shape memory alloys. In metallurgy, a shape memory alloy is an alloy that can be deformed when cold but returns it pre-deformed and shaped when heated. It may also be called memory metal, memory alloy, smart alloy, or a muscle wire. Parts made of shape memory alloys can be lightweighted, solid-state alternatives to conventional actuators such as hydraulic, pneumatic and motor-based systems that can also be used to make hermetic joints in metal tubing. And next slide is applications. First one aircrafts, second one is orthopedic surgery, dental braces, robotics, reducing vibration of helicopter blades, and the last one is smart fabrics. The next slide is merits and demerits of smart materials. First we take merits. Biocompatibility, simplicity, compactness, and safety mechanism. And demerits of smart materials are more expensive, low energy efficiency, complex control, and limited bandwidth. And the conclusion. Today, the most promising technologies for lifetime efficiencies and improved reliability include the use of smart materials and structures. Understanding and controlling the composition and microstructure of any new material are the ultimate objectives of research in this field, and is crucial to the production of good smart materials. New and advanced materials will definitely enhance our quality of our life. Any further questions?
Yes. Which is the best technique for the fabrication of metallic foam, casting or powder metallurgy?
Well, it depends on our final application, but powder technology is easy and cheap besides good and mechanical properties. Thank you. Have a nice day.